Welcome back. We're in Vectors and Projectiles unit here. Worksheet number 1, question number 2. If, and this is a big thing, if the ending velocity, you might say, the velocity is equal to the original one of the velocities plus another velocity, is the v, the ending velocity, necessarily greater than the two components, the two bits that made it up. Now that's an if statement. We know that this statement is not true, but let's look and see and prove that it really isn't true. Let's start with simple cases here. What if V1 looked something like this? Great. Let's give V1, well, let's do it without numbers and then we can add numbers to it. If we were going to go and add that straight to it, if we were working in a one-dimensional line, we could have V2 that looks like that. We would add those things together, and and we would know that the resultant vector, or v, large V, no subscript, V total you might say, would be like the remaining bit here. So it'd be something that's like relatively short there, and that would be total V. What's going on there? Let's put some numbers to it. Let me do that in red. What if this thing was 10 and this thing was 5, or you might even say -5 since it's going to the left in this case. Now when I add those things together, I'm only going to get 5, and 5 is less than the 2 there. Why? Where did that negative come from? Well, that came from direction, the fact that it's going the opposite direction from one another, and this is following the Cartesian coordinate plane that positive is negative, or positive is to the right and negative is to the left. You could define it differently, but the point is that the directions that they're going are exactly opposite. Now that becomes a little bit more complex when we go from a one-dimensional case, this is a 1D case right here, and we go to a 2D case instead, and the same is going to be true for three-dimensional and greater than that as well. But if we look at 2, are they necessarily greater than one another? Well, it becomes a little bit more interesting. Let's say that V1 still looks like this and it's going to the right. We'll go ahead and use the Cartesian coordinate plane as we generally know and love. And positive to the right, negative to the left, positive upwards, negative downwards, that makes sense. And then I go and I look at V2, and what if V2 looks like this? That's great. Let's put some numbers to that. What if V2 is 5, and you would say, oh, it's going in the negative direction downwards there, so I'm going to put in the negative bit, my direction in there, so when I mathematically add these things together, I get something that makes sense. And then similarly for the blue one, I'd add up 10. Now, let me just point out before I even do this, that what I'm going to do is wrong, and to prove that it wouldn't make sense to do it this way. So I would add those together, and this would imply that my ending V would be 5, just like in the previous case. But you should intuit that that doesn't seem to make sense, because V2 isn't going directly against V1. Instead, it's going completely perpendicular to it. So in this case, if it was like velocities, you'd still have the rightwards velocity here, but now you would just like gain some downwards velocity on top of that rightwards velocity. Maybe some ball was like thrown to the right-hand side to give it this blue velocity to the right, and then gravity a second later, or a half second later in this case, caused it to change its velocity, speed up, but going down. Well, we know that the new resultant vector should be greater than this. It should be greater than the sums of, well, it should be greater than either of the bits that make it up, if they're not going directly against each other anyways. Should be. So should be. So how do we actually do this? Well, we need to add it within vector space here, and that means that we need to be having them go tip to tail as I drew them here already. And this V is the correct one, so maybe I'll put wrong next to that one right there. Now the purple is going to be correct here, where this makes up a right triangle here, and now I can go solve this. And now I can use Pythagorean theorem that V squared, the resultant vector there, is going to be the original bit plus the other original bit and the square of those guys. And so that means that V, my resultant vector there, is just the square root of all of that stuff there. And so I go and put that in. So I'm going to get 10 squared plus my negative 5, but I'm squaring that, so it'll become positive anyways. And so I get 100 plus 25, and so I'm going to have root of 125, and root of 125 is 5 root 25. Yeah, because it's 5 times 25. Yeah, so it's 5, and then root 5 is that, and so that's my resultant vector. Now we can see that this is much greater than 5, as we said before. 5 root 5 is going to be a whole lot greater as root 5 is. Let's go ahead and let's get a decimal answer of that, just to prove that a little bit more, that comes out to be about 11.18. So yeah, and then that's going at this angle right there, and we could even go and find that angle by doing, well, I'll just go ahead and do that, by doing either tangent sine or cosine. I'll go ahead and use tangent here. Actually, I'm going to go ahead and use sine, since we have a nice one. I'm going to use cosine. It doesn't matter which one we use, but I'm going to use cosine of some angle there. Let's say that's angle alpha, and angle alpha is going to be 10 over the hypotenuse there, 5 root 5. And so now I go and I take the inverse cosine of both sides there, 10 over 5 root 5. Hey, look, that simplifies there. So that becomes 2 over root 5, or if the proper math way to write that is going to be 2 root 5 over 5. But it doesn't matter which way you write that. We'll just go ahead and get a decimal either way anyways. And I'll do this in degrees. Most of the things we do in this course are in degrees, but they don't have to be. If you like radians, you can go ahead and do it in radians. That'd be fine. And so we get that many degrees. Now I go, wait, hold on a second. That's measured down below. That's the opposite way of really measuring it normally. So that is a negative there. And so make sure that you always put in the correct direction with that. Okay, cool. That's it, and that's probably more than what you bargained for. Have a nice day. See ya.